Hello again, Group B. I hope you are all doing well. Today we are talking about Topic 2 and Lesson 4. Just a friendly reminder, tomorrow's Friday. We're going to have a checkpoint day tomorrow. And then we have another week of lessons. And then the following week, we do have a test coming up. So just a general reminder about how this works again. You've already completed the exit ticket. Now you're watching the video. When the video is complete, you'll notice the next workbook page will unlock for you in Schoology. After you complete that workbook page, which are the same problems as the ones that we're doing together right now, you can complete the last workbook page in your completion folder in Schoology. Please make sure you complete the exit ticket with that and turn that back in, because remember, that's your daily grade. So I hope all is well. Let me know anytime if you have any questions. Here was your do now. Owen and Jen found the slope between points A and B. So we are wondering who is right. Now if I zoom in on this graph, hopefully you're remembering that a line going this way is a positive slope, because if we think about it with our money, that would be a good thing. Eventually, the stock market is hopefully going to do this, because right now the stock market is unfortunately doing this very quickly, and that is not a good thing. People are losing a lot of money. That's a negative slope. So when I look at this line, hopefully you're noticing from left to right, we are going down. Therefore, we need a negative slope. Now, if I look at Owen and Jen's responses, Owen has a negative slope and Jen has a negative slope. So we can't eliminate either of them quite yet with just that information. How do we find slope? Remember, slope is the same thing as rise over run. Remember, rise goes up or down and run goes sideways. So if I count my rise, I'm noticing my start is at point A and my end is at point B. So I need to count how many lines down do I go. Always keep in mind, what are you counting by over here? In this situation, we're counting by ones. So I'm going to count by ones. One, whoops, ooh, that was fun. Sorry, let me start that over. 1, 2, 3, 4, 5. Now if I'm going down, that means I'm going down 5. Now I'm running sideways, 1, 2, 3, 4, 5, 6. So my run value is 6. My negative 5 goes on top. That's my rise. My run is 6. That goes on bottom. Therefore, if I compare this to Owen or to Jen, I can see that Owen is correct. I'll give you a moment to think about what Jen maybe actually did instead. Hopefully what your brain is thinking is that she reversed the numbers. She did run over rise. Remember, we do not want to do that. We always need to do rise over run. So that was your do now. Let's go ahead and get to today's lesson. Determine if the set of ordered pairs represents a linear function. So a linear function is exactly what it sounds like. Do you see how the word line is in it? Therefore, if our graph makes a straight line, something like this, then that's a linear function. If we notice our points are all over the place, then that's a non-linear function. So what we're looking for today is we are looking for things that make lines, or graphs that make lines. Let's go ahead and get rid of those, because you guys know I like to write a ton. So let's go ahead and look over here. Right now, what we have is we have an x value and we have a y value. Remember, your y value goes up and your x value goes sideways. So if I'm to graph these, what I would need to do is I would need to find point A has an x value of 1, so I go over 1, and a y value of 2. Then I go up 2 and make a point. Let me erase those blue lines for you now. Oh, I lost my highlight. 1 second. Point B has the ordered pair of 3, 6. It's right here. So that means I go over 3 to the right. 1, 2, 3. Up 6. 1, 2, 3, 4, 5, 6. And make my point. My next point that I have is 5, 10. Over 5. 1, 2, 3, 4, 5. Up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, the directions are asking us to find if it's a linear or non-linear. If I have a straight line, it's nice because I can make sure it's straight with my notability function here. Do you see how all of my points are on a line? Therefore, it is linear. Now, what is this business right here? They're wanting us to find the slope between points A and B. So let me get rid of all my stuff up here. If I have point A, remember I want change in Y over change in X. So let's start with our Y value. A Y value is 2. B Y value is 6. 6 minus 2 over, now it's very, very important. Do you see how I started with my 6 down here? That means I need to start with my 3 first. So 3 minus 1 goes on the bottom. 6 minus 2 is 4. 3 minus 1 is 2. This line means to divide. 4 divided by 2 is 2. So my slope for this first problem between A and B is 2. Let's go ahead and do the next one. Let me change colors here. You guys have never experienced my color craziness with all of these things. Between B and C, my B and C value for Y is 10 and 6. Now I'm going to do this one first and this one second just because 10 is larger than 6. It'll be easier. So I have 10 minus 6 over, now I did the 10 first, so I need to do 5 first. 5 minus 3. 10 minus 6 is 4. 5 minus 3 is 2. That line means to divide. 4 divided by 2 is 2. Lastly, we now need to find the slope between A and C. Give me a second here to erase. There we go. A Y value is 10. I'm sorry, C Y value is 10. A Y value is 2. So 10 minus 2 over 5 minus 1. 10 minus 2 is 8. 5 minus 1 is 4. 8 divided by 4 equals 2. Now, hopefully you're making an observation here, Group B. I'm really hoping that you're seeing this connection right here. 2, 2, 2. If all of the lines have a slope that's the same, it's going to be linear. If you're finding once you do your math, you have a 2 for a slope, and then maybe a -3, and then maybe a 4. Do you see how these are different? Different slopes would mean nonlinear. But the fact that 2 and 2 and 2 are the slopes that you find mean that this line is linear. Let's try another one. Determine if the set of ordered pairs represents a linear function. So we're going to do the exact same thing. This time, let's go ahead and start with our slopes. Remember, slope is change in Y over change in X. If I look at my Y values between A and B, I have this number and this number. It's easier for me to start with 2 because then I don't have to deal with a negative. 2 minus 1 over my X value would be a 2 and my X value would be a 1. 2 minus 1 is 1. 2 minus 1 is 1. That's a slope of 1. Now let's do the same thing for points B and C. Okay, for B, I have a Y value of 2, and C, I have a Y value of 8. Let's go ahead and do 8 minus 2 because the 8's bigger. Therefore, I need to do 3 first. 3 minus 2. 8 minus 2 is 6. 3 minus 2 is 1. 6 divided by 1 is 6. So looking at these slopes and what I just talked about, if I have a 1 and I have a 6, are those equal or are they not equal? They are not equal, therefore I have a nonlinear function because the rate of change, this is my change of 1 and 6, is not constant. So one more time, if I have different slopes, it's nonlinear. And if I have different slopes, it would not be constant. Let's go ahead and start graphing these two just to make sure that we are correct. For point A, I have 1, 1 over 1. Be careful, this is not 1 in this situation. We're going over 2 spaces and then up 1 space because of what they're counting by. Point B is at 2, 2, over 2, remember, over 1, 2, up 2, 1, 2. Now the third point, point C, is at 3, 8, over 3, and up 8. Now if I try to connect these two initially make a line. But as I try to move this, you can see that that third point up on top does not go with my line. Therefore, this is nonlinear. If I connected these, it would look something like this. Not a straight line, so not linear. Let's go through a third example. Remember, when we zoom on in, same directions, determine if the set of ordered pairs represents a linear function. So let's go ahead and find the rate of change between points A and B. A, we have 4 and 2 for my y values. So I'm just going to pick 4 first because it's larger. If I pick 4 first, then I have to pick my x value first for point A, so 0 minus 1. 4 minus 2 is 2. 0 minus 1 is negative 1. 2 divided by negative 1 equals negative 2. So my slope between A and B is negative 2. Let's do the same thing, but between points B and C. My y value is 2 and 6, so I'm going to pick 6 first minus 2. If I pick 6 first, I have to pick 2 first. 2 minus 1. 6 minus 2 is 4. 2 minus 1 is 1. 4 divided by 1 equals 4. Here's the slope, and here's the slope. Is that linear, or is that nonlinear? It would be nonlinear because our numbers are different. So therefore, is the rate of change constant, or is it not? It is not because it's nonlinear. Let's check with our graph. So let's go ahead and plot these points. I'm going to erase a little bit over here so it doesn't get so crazy. These are the points we're going to plot: 0, 4, 1, 2, and 2, 6. 0 up 4 is my first point. Over 1 up 2 is my second point, and over 2 up 6. Now this one's very, very clear that if I were to follow these points, I would go down and then up. It kind of makes like a check mark. That is non-linear. Even though I can connect them with a straight line, remember, linear would mean something like this. Every single point would fit on that line. Hopefully what I'm saying today is making sense. If it is not, please make sure you reach out and ask a question. I am available with my Google phone number, which is on the top of our Schoology page, or my email, which is also available on the top of our Schoology page. And you can always send me a message on Schoology too, whatever is easiest for you. So hope you have a great day, and I will talk to you all tomorrow.